In this problem, we're given some parametric equations, and we're being asked to find the length of the curve from 0 to pi. So the length of the curve, which I'll call s, is equal to the definite integral from 0 to pi. And basically, it's going to be dx d theta squared plus dy d theta squared. And then you're going to take the square root of that and then integrate. So looks like it might be pretty messy in this problem. So first, let's go ahead and find the derivatives. Here a is a constant, so when we differentiate both of these, the a will kind of just hang out and we can just focus on these derivatives here. Also, we're going to be using the product rule, so let me just refresh your memory. If you have f times g, where f is your first function and g is your second, it's the derivative of the first times the second plus the first times the derivative of the second. Okay, let's go ahead and find each of the derivatives here. So I'll do it up here. So let's see, dx d theta. Let's do that one first. So the a hangs out, so parentheses. The derivative of cosine is negative sine, so that part's pretty easy. So negative sine theta. And then now plus, we have to use the product rule here. So let's see, the derivative of theta, that's the derivative of the first, is 1 times the second, which is sine theta, plus the first, which is theta, times the derivative of the second, which is cosine theta. Oh, this is really nice. Look at that. The sines cancel. So we end up with a theta cosine theta. So this is dx d theta. I'm going to just write it down again and put it in a box so we don't lose it. That worked out really nice. I have not done this problem. I just said, hey, let me do this. It looks interesting. So I'm very happy that worked out. Let's find dy d theta. So same thing, the a is a constant, so it's going to hang out. So a, parentheses. And the derivative of sine is cosine, so that part's not hard. So we just get cosine theta. Now here we have the minus. I'm going to leave the minus out and then just really focus on this piece here. So the derivative of theta is 1. That's the derivative of the first times the second plus the first, which is theta, times the derivative of cosine, which is negative sine theta. I'm going to go over that again. So basically, I left the minus on the outside. We did the derivative of the first, which is 1, times the second, which is cosine, plus the first, which is theta, times the derivative of cosine, which is negative sine. Look at this. Look, they go away. So we get, oh, look, negative and negative. That's going to be a positive. It'll be a theta sine theta. So this is our dy d theta. Really nice. Okay, so now we can just plug everything into the formula. Let me switch colors here. So s is equal to the definite integral from 0 to pi. You can use L, by the way, for length if you want. I just decided to use s. And then so dx d theta squared. So basically we're squaring this, right? That's what this says. So it'll be a squared theta squared cosine squared. So it'll be a squared theta squared cosine squared theta. Plus, and then dy d theta squared will be a squared theta squared sine squared. Good stuff. And then we have this giant square root here, and then d theta. This should work out. You know, these problems, if you just make these up, it won't work. These problems are usually rigged to work out nicely, because in general, I mean, if you just make up x and y, what are the chances you'll be able to integrate, you know, something like this? So let's see. Oh, I see. We can pull out an a squared theta squared. So we can write this as the square root of a squared theta squared. Okay, and then square root of cosine squared theta plus sine squared theta, right? You can pull it out and then write it as 2 square roots, right? Because you have one here, you have one here. So you pull it out, we wrote it here, and then we're left with cosine squared plus sine squared. All right, if we assume a is positive and theta is positive, this is just going to be, well, theta actually is positive or 0 because we're integrating between 0 and pi, and those are the range of values for theta. So we're just going to get theta when we take the square root of theta squared. So this will be a theta, and this is 1, right? This is a famous identity, so this is the square root of 1, d theta, and we're going from 0 to pi. All right, so the square root of 1 is 1, so we just get the integral from 0 to pi of a times theta d theta. And we're integrating with respect to theta, right? Because a is a constant. So we just use the power rule here. There's a 1, so it'll be a times theta squared over 2, right? Just add 1 and divide, and then we're going from 0 to pi. So we plug in the pi first, so we get a pi squared over 2, subtract, plug in the 0, a 0 squared over 2. That's just going to be a times pi squared over 2. That would be the length of the curve. This part here is just 0. I hope this video has been helpful. Good luck.